Hi, everybody. Uh, our plan today is to finish section 4.1. Before I start in on that, though, I want to ask you guys, do we have any questions from homeworks to this point? So I think you guys should have assigned and completed worksheets 1 and 2 for the problem set this weekend. And then on the asynchronous day, I think I asked you to do 1 through 16. Do we have any questions on any of that stuff before we dive in? Alondra. Worksheet 2, number 2, and number 8. Okay. Okay, let's take a look. There you are, little friend. Okay, so we're gonna start by drawing a little picture. And the first thing that I like to do is to identify what two quadrants are covered by our interval. So those are both positive values. So I know when I do my counting, I'm going to be counting counterclockwise. So 1/2 pi, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, and that's now covered from 2 pi to 3 pi, right? Then I'm going to do my all silly turtles crawl. I observe here that cosine inverse of 0.56 is the same thing as saying cosine of theta equals 0.56. So that's positive. The two quadrants where cosine is positive are the A quadrant, A for all sine, cosine, and tangent are positive, and the C quadrant for just cosine is positive. So I can see then that my terminal side of my angle theta should be in quadrant 1. Alondra, are you okay with how I did that? So I'm going to draw my initial side, and I'll just draw my terminal side somewhere in there. And then to get to this, I have to go like that. So there's my theta. My alpha is going to be the angle formed between the terminal side and the x-axis. So if I want to look now at the relationship between theta, alpha, and that side of the x-axis that makes the other arm of alpha, I can say, okay, well, theta definitely goes past 2 pi. And how far past 2 pi does it go? It goes alpha past. Right? 'Cause if I think about it, it's like here's theta. I go to here. That's 2 pi. And then I go to there. That's alpha more. And I remember that alpha is always going to be the inverse of the absolute value of the inside. And at that point, it's calculator time for me. So 2 pi plus cosine inverse 0.56. So 726-ish should be my answer. I observe that if I do cosine of 726, I get exactly 0.56. And I notice that 726 is in between 2 pi, which is 6.28, and 3 pi, which is 9.42. So I'm convinced that this answer has to be correct. And then you said 8 was the other one, right? Was that okay so far, Alondra? Okay. All right, so let's do 8 this time. So again, I'm going to start the same way. This one, though, is a little bit different because I noticed that my angles on my interval are negative. So this time, instead of counting counterclockwise, I have to count clockwise. So negative half a pi, negative 1 pi. And I'm done. That tells me that we have to be somewhere in quadrants 3 and 4. I notice that the cosine here is negative. The 2 quadrants in which cosine is negative is in quadrants 2 and quadrants 3, because I notice in quadrants 1 and 4, cosine is positive because it's all, and cosine is positive in quadrant 4 because it's the C. So far, so good, Landra? Okay, so I'm going to draw here. So there's my theta. There's my alpha. And now I'm going to try to think about, okay, what is the equation that relates theta, alpha, and negative pi together? Now this is the one where it's a little bit tricky here. So if I think about this, instead of thinking about before or past, I need to think about bigger and smaller. So is theta bigger or smaller than negative pi? It's bigger because negative pi is more negative. Ugh, I know. So theta plus something, well, not plus though, right? If theta is too big, we should be subtracting something, right? So if theta is bigger than negative pi, to make theta get to negative pi, we have to make it smaller, so we have to subtract. What are we going to have to subtract? Well, alpha in this case. Or I can say that if I add alpha to both sides, theta is negative pi plus alpha, and our alpha in this case is going to be cosine inverse of the absolute value, 0.62. And then it should be calculator time for me. Now, when I type it in, I never do the absolute value. I just do that part in my head, right? Absolute value of negative 0.62. I don't need to do that in my calculator. I can just make it positive all by myself. So I get about 2.24. Negative 2.24, excuse me. Alondra, is that okay? Again, the trickiest part about that is making sure you're adding or subtracting the alpha appropriately. Again, we can check this. If I did cosine of my answer, I get negative 0.62 as I should, and clearly negative 2.2 is between negative pi, negative 3.14, and 0. So I'm good there. If I had accidentally subtracted alpha instead of adding it, and I go to check, I'll notice that if I do the cosine of that answer, I get the wrong sign. Oh, I did get the right sign, but this is not in my interval though, right? Which is usually that's why we're doing the check at the end. That's because it usually can catch that stuff. So if you get the right answer, but it's in the wrong spot, it's not in between, in this case, negative pi and 0, probably it's an alpha issue. You added when you should have subtracted, or subtracted when you should have added. 9 out of 10 times it's something like that. Cool. Okay. Anybody else? Okay. Let's finish up 4.1 today then. So I want to remind ourselves about the ranges for sine inverse, cosine inverse, and tan inverse. So we talked about these already, but we're going to be using these ideas again. So probably need to remind us. So we talked about this earlier, the very first day when we talked about 4.1, but we haven't used these since that day. So just wanted to restate this, as I'm going to be using these things again here in a moment. So I figured we should write them back down again. And now let's do some examples. Let's say I want to do cosine inverse of tangent of 45 degrees. So I'm going to start with the inside. So I'm going to be looking at tangent of 45 to start. Now, 45 degrees I recognize as a unit circle angle. So I'm going to go pull out my unit circle to do this. Yeah. It's not where I told you to go. Paste in where I tell you to. There you go. All right. So I locate 45 degrees. And I remember on the unit circle, tangent is y over x. And the y coordinate was root 2 over 2. And the x coordinate was also root 2 over 2. What do I get when I divide those two numbers? Only one person answered me. You guys can do better than that. It's going to be 1, right? If I divide some number by itself, I better doggone get 1. So what I have then is cosine inverse of 1. And then I have to remember the range for cosine is 0 to pi. So what quadrants are covered by 0 to pi? Quadrants 1 and 2. So I'm just going to go to my unit circle, look in quadrants 1 and 2. for a place where, remind me, is cosine x or y on the unit circle? X, where cosine is 1. Well, that happens there at 0. So cosine inverse of 1 should be 0. Is that radians or degrees? What do you guys think? Degrees, great. Why did you say degrees?
Because it has a degree in the unit circle.
Well, I would say because the problem was in degrees, right? We started off with an angle in degrees. Typically, whatever the unit is when we start is the unit when we end, unless the directions would tell you otherwise. How'd you feel on that? Not a big deal, right? Still kind of using the unit circle, kind of like a worksheet 1 problem. Let's do another example. Oh, we didn't mention this yet. Have we talked about what like arctan or arc cosine or arc sine means? Guess what it means? The same as inverse. So this is just the same thing as like tan inverse. So you see arc cosine or arc sine or arc tan just means sine inverse, cosine inverse, tan inverse. Just another notation that means the same thing. So just like before, we're going to start the same way. I recognize 2 pi over 3 as a unit circle value. So I'm going to go to my unit circle, locate 2 pi over 3. So y is root 3 over 2, and x is negative 1/2. Now, I could reduce that, but I'm not going to bother with it, because what is the outer part of my function here? Tan inverse, where I want the actual x and y's there. So remember, the range for tan inverse is negative pi over 2 to positive pi over 2. That's quadrants 1 and 4. So I'm looking for a place where y is root 3 over 2 and x is negative 1/2, or where the y is negative root 3 over 2 and the x is positive 1/2, right? Because we know if I have a negative sign in the fraction, that negative could really be with the numerator or the denominator. Everybody's okay with that? So if I go and I look, well, y over x. Obviously, this one can't happen because the x's are always positive in quadrants 1 and 4. So I got to definitely be looking for this one. There I go. So we should have that theta is 5 pi over 3. Uh-oh! Is 5 pi over 3 in between negative pi over 2 and positive pi over 2? Nope. Did we make a mistake? Nope. What do we just need to do? Yeah, we just need to see if we can find something coterminal by adding or subtracting 2 pi. So what do I have to do to subtract 2 pi from 5 pi over 3? I need a common denominator. That common denominator would be 3. So 5 pi minus 6 pi is negative pi. and the denominator is 3. Negative pi over 3 is definitely between negative pi over 2 and positive pi over 2, because I know a third is less than a half. And there's my answer. What do you guys think on this? Not too bad, right? Basically just using the unit circle like we've done in chapter 2 and then also with worksheet 2, but we're like layering 2 problems together now. The thing you have to remember is that we're using the ranges for our trig functions. That's what's giving us the interval as to where to look on the unit circle. So if they don't give you an interval, what interval are you using? These ones. Okay. All right. I have one more type of problem that I want to look at. Okay. Our directions here say find an algebraic expression equivalent to sine of arc cosine of 2x. When we say algebraic expression, what do we mean there? Excellent, yeah, that our answer could have an x in it, right? We're going to find an answer to this equation, but it probably is going to have an x in it. It might not, but it could, right? So that's all it's saying. So we are going to start this just like we did before. We're going to build from the inside out. But let's think a minute about this for a minute. Remember, arc cosine is the same as cosine inverse. When I do a sine inverse, cosine inverse, or tangent inverse of something, what am I getting back? What is the answer when I do sine inverse, cosine inverse, or tan inverse of something? I'm getting an angle measure, right? So this is like our angle theta. So this would be equivalent to saying cosine theta is equal to 2x, right? Is everybody okay with what we've done there? We do this kind of manipulation all the time when we did the worksheet 2 problems to decide where the things were going to be positive or negative at, right? So here's what I'm going to do now is I'm going to think about cosine theta equals 2x as a right triangle problem. So I'm going all the way back to my geometric definition for sine, cosine, and tangent. In a right triangle, what is cosine theta equal to? Not opposite. Adjacent over hypotenuse is correct. Remember, it's SOHCAHTOA. So we use that part. So if I think about 2x as just 2x over 1, the adjacent side should be 2x, and the hypotenuse should be 1. Everybody good with the reasoning there? Now what I'm going to do is I'm going to find the third side of this triangle. I'm going to refer to this as y. I want that third side of my right triangle in terms of x. What equation can I use that relates the sides 2x, y, and 1 together? The Pythagorean theorem. When I write the Pythagorean theorem, which is the one side I have to be careful about what it is? The hypotenuse. The hypotenuse always has to be c, what it's equal to, right? So I say 2x squared plus y squared is equal to 1 squared. Everybody feel good? What do I get when I simplify the expression quantity 2x squared? 4x squared, right? 2x times 2x is 4x squared. Everybody's okay with how he did that? And 1 squared, well, that's just 1 still. So if I want to get the y by itself, I'm going to subtract 4x squared from both sides. And then we'll square root both sides. Yes. When I square both sides of an equation, what do I need to have? Plus or minus. But hold on a second, Mr. Kulik. What is y representing? It's a side length in a triangle, right? Can that be negative? No! So on these type of problems, we don't really have to worry about the plus or minus. It'll always just be positive because we're always going to be relating this to a side length in a triangle. So in place of y, we're going to use square root 1 minus 4x squared. Common question here. Mr. Kulik, can I just write this as like 1 minus 2x? What do you guys think? No! Why not? What you're doing is you're saying that this is true, right? The only operations that you know about that distribute across addition and subtraction are multiplication and division. Radicals do not distribute. Exponents don't distribute. Sine, cosine, tangent don't distribute. Logs don't distribute. Nothing you'll see until you take a calculus course distributes other than multiplication and division. So if there's a plus or minus sign in between two things, you best not be distributing. Just to be clear. Okay. Let's look at where we're at now. So this thing in here we've replaced with theta. And the theta we're talking about is this theta here. So to figure out sine of theta, where theta is an angle inside a right triangle, what can I do? SOHCAHTOA. Can just be opposite over hypotenuse. Well, what's the opposite in this case? Square root 1 minus 4x squared. And the hypotenuse is 1. Or we can simplify that down to just 1 minus 4x squared. And we're done. Well, that's not so bad. Now, I wrote down a lot of stuff here, right? But I wanted to really make sure I was really thorough about how I was building these triangles, where all this information was coming from. So if you're going back and you're looking for an example, hopefully it's easy to follow what I did there. Shall we do one more? Yeah, let's do one more, right? So you guys are going to be doing worksheet 4 for me next as a homework assignment. I'm just going to grab worksheet 4, and we'll do like the first problem from worksheet 4 here together. All right. So we're going to think about cosecant inverse of x as my theta. So cosecant of theta should equal x. In a right triangle, with acute angle theta, what is cosecant equal to? Okay, cosecant is 1 over sine. So in a right triangle, sine is opposite over hypotenuse. So cosecant should be hypotenuse over opposite. So the hypotenuse should be x, and the side opposite should be 1. Feel okay there? So to solve for the other side, I can say 1 squared plus y squared equals x squared. I'll subtract 1 from both sides, and then square root both sides. So now that I have my right triangle, if I do cosine of theta, that is adjacent over hypotenuse. And I'm all done. So, overview. For each of these types of problems, you use the inner piece to build your right triangle. Once you have your right triangle built, you're going to evaluate the outer piece using that right triangle. That's basically the pattern every single time. Does that feel okay? In addition to worksheet 4, I have a delta math assignment for you. So let's take a look at that. I've titled this Chapter 4 Delta Math. There we go. So I'm going to pretend to be one of you guys. So Chapter 4 Delta Math has just two questions in it. The first is quadrants of a trig function. This is a new kind of problem, though, because it's timed. And what you need to do is you need to get 15 correct answers in a row before time expires. So notice what it's asking for is the quadrants in which this could lie. So where can tangent be positive? 1 and 3. Where can tangent be negative? 2 and 4. Where can cosecant be negative? The same place sine can be negative, which is quadrants 3 and 4. And you keep on going like this. But what happens if I get a wrong answer? It immediately stops your time, tells you you have a wrong answer, and you have to restart until you get 15 in a row. It's not insane. It's perfectly doable. Jake Rose did it. You'll be able to do it. Yeah. Doesn't count it as you have to do it until you can do it. Huh?
No, it does.
It doesn't count it as a completed response, though. It doesn't stop you when time runs out. It lets you go to the end, but it doesn't count it as a completed response. The other type of question says combined radian angles. So pi plus 3 pi over 4. If I make a common denominator, that's 7 pi over 4. Pi over 2 minus pi, well, that's negative pi over 2. Pi over 4 minus pi is negative 3 pi over 4. And I just go like this, and I try, oh no, I got a wrong answer, and now I have to restart. So again, that's your other type of problem. You have to get 15 in a row inside of the 100 seconds for a correct response. Everybody's okay with that? But that's it. That's the whole delta math. It's just those two problems. Did you get it?
No, I did not.
Oh, okay. Here's the thing, guys. You're gonna make mistakes for a while, or you're gonna be too slow for a while, but it will, if you try it, it will work. Okay? Be patient. You can do this. And then I have one other thing that I need your guys' help with. So on our My Notre Dame page, if you look down at the announcement, there's an announcement called Surveys. There's 12 surveys that I would like you to complete. They're all 1 or 2 question surveys. They're like no big deal. So like if I click on one, you just hit the record your thing. And then it's just asking like, what is your average daily cell phone screen time? If you need to look up your cell phone on your cell phone that gives you your screen time, you enter your answers, hours and minutes. How much sleep did you get last night? Give the hours and minutes. So 8 hours, and then you pick your minutes. Rounded to the nearest 15 minutes. That's one survey completed, right? Like, these are not lengthy, but please, this is for the IB Math Studies course, or I'm sorry, IBSL course. They need responses to their surveys. Please do this. Please do it today. In fact, start with this. This would make my life massively, massively easier if we can get some more responses to these things, because we've been really unsuccessful in doing so. If you're a senior and you've already been asked to do this inside your community time and you have completed all of these, then you don't need to do anything. Otherwise, if you are not one of those people, please answer these.
How much we get sleep?
Yeah.
A bunch of,
These are for students' math projects. These are just some surveys. So there's 12 of them. There's not a ton. They're all here on My Notre Dame.
how much sleep is next?
I don't know, but his survey is about, I think, stress relief or time meditating and stress level. So again, that's the dealio. So please take a few minutes, complete the 12 surveys. I don't think that they should really take much longer than a minute or two per. Some of them even less than that. Yes, sir.
What's due this Sunday?
So far, the things that would be due this Sunday would be the 1 through 16 from the asynchronous day, and then worksheet 4, and the delta math. But the delta math is like 2 questions.
Yeah.
The problem is they're timed, and you have to get the number of right responses inside of the time limit, which makes it kind of fun. It's like a game. It's like 7 seconds per correct response, so you don't really have to rush. Okay. You finished it? That's great. It did not even come close to 10 minutes. But you might have taken 10 tries. But that's okay. I'm going to stop talking now. You guys feel good about what it is that you should be working on?